Hello everyone, in today's class we shall learn about few terms. So the first one is gravitational field. So gravitational field, it is the region in which a particle experiences gravitational force. So imagine a particle that is present in a particular region. Imagine a particle that is present in a particular region, and in that particular region it experiences certain amount of gravitational force. So we are considering a particle that is present in a one particular region, and that particular region it is experiencing gravitational force. So if all these things can happen to that particle, that particular region is said to be gravitational field. So the second one is gravitational potential energy. This gravitational potential energy is represented by the term V. So by the capital letter V, we represent this gravitational potential energy. So this gravitational potential energy at a point in the gravitational field is the work done in displacing the body from infinity to that particular point. So remember this. So gravitational potential energy at a point in the gravitational field. So gravitational potential energy at a point in the gravitational field. So it should happen in the gravitational field itself. Here work has to be done. So work done in displacing the body. So displacing means moving. Okay, it is moving from one place to another place. That is displacing. Displacing the body from infinity to that point. We just don't know which point it is. Okay, so where it is the point. So that body, we don't know where the body is. So at what distance it is, we don't know. So we are considering infinity here. We just don't know what the exact amount of distance. So from that infinity to that particular point. So that point is present in the gravitational field. So that is known as gravitational potential energy. So gravitational potential energy at a point in the gravitational field is the work done in displacing the body from infinity to that point is called as gravitational potential energy. The next topic is expression for gravitational potential energy. So gravitational potential energy is represented by the term capital letter V. So here let us consider our Earth, which has a mass m, which has a center O, which has a radius r. This is the same old story here. So we are considering our Earth, which has a mass m, which has a center O and has a radius r. Let A be a point which is at the distance r from the center of the Earth. Let us consider A. Let us consider A to be a point from a distance small letter r from the center of the Earth. So let us also consider A, B and C, 2 points that are separated by a distance dx. So let us consider B and C, 2 points which are separated by a distance dx. So let us also consider a particle which is placed at the point B, and that particle is at the distance x from the center of the Earth. So let us consider a particle B, which is let us consider a particle of mass small m, okay, which is placed at the point B, which is at the distance x from the center of the Earth. So I'll repeat again. So let us consider our Earth, which has a mass m, a center O and radius capital letter R. So let A be a point at a distance small letter r from the center of the Earth. Let B and C be the 2 points that are separated by a distance dx. So let us also consider a particle which is placed at the point B, which is at the distance x from the center of the Earth. So this is what we need to know from this. We can explain this from this figure. So after this, so what we have to do is from Newton's law of gravitation, from Newton's law of gravitation, we know that the force is equal to G divided by x square. So we know this because here we have a body, our Earth, which has a mass m, and we have also placed a particle at the point B, which does have a mass small letter m. So the force between them will be Gmm by, and the distance, which is x here. So the distance is x square. So we know this. So F is equal to Gmm by x square. Next, the work done in moving the body or the particle from B to C. So, work done in moving the particle from B to C. We are moving the particle from B to C here. So that work done, work has to be done while moving the particle from B to C. That is what we learned in gravitational potential energy. That is what I taught you. Okay. So here, that work done we shall write. So that is dW is equal to F into dx. So this is the work done in moving the particle from B to C. So after this, we shall substitute our force in this equation. Let us substitute this in our equation. So it becomes dW is equal to G m by x square into dx. So this is what it becomes. So after this, what we have to do is we shall write the total work done. So total work done in displacing the particle, displacing the particle from x is equal to infinity to x is equal to r. So here I have taken work done in displacing the particle from x is equal to infinity to x is equal to r. So we have taken from infinity to r here. So this is why because here I told you that I have placed a particle at the point B here. So but I really don't know where this point B is. So exactly at what distance it is situated from the earth, I just don't know. So for that reason itself, without knowing that distance, so I have taken that it has infinity. It could be at any number of distance. Okay, the distance between earth and that particle is very huge, very humongous. Okay, for that reason itself, I have taken infinity, and it can come on to r here. So here, the particle can come as close to earth with the distance r here. So this is what it can come. It can come very close to the surface of the earth. So it can come until our distance r here. So this is the reason why I have taken x is equal to infinity to x is equal to r. So here, what it becomes, I will write the total work done here. That is W is equal to integration of x is equal to infinity to x is equal to r into dw. So this is what it will be. So W is equal to integration of infinity to r into dw. So now I'll substitute the dw onto this equation. So it will be work done is equal to integration of infinity to r. So dw is Gm divided by x square into dx. So now I have to integrate this. So after integration, work done will be equal to minus GMM divided by R. So this is what I'll get after integration. So you people will learn about this integration and differentiation in your second PU classes. That you will learn in your mathematics classes. So don't worry about that now. So for that reason itself, so I have directed directly. So your marks will not be deducted for doing this in your examination. But don't worry about it. You can write directly here. So you can write after integration and you can write the last step directly. Okay, don't worry about this. So you have to know this. So after this, so the work done is equal to gravitational potential energy. So that is W is equal to potential energy is equal to minus GMM by R. So here the potential energy can be written. We have that potential energy can also be named in the term capital letter V here. So V is equal to minus GMM by R. So this is the expression for gravitational potential energy. So here negative symbol indicates that work has been done by the gravitational force. So the negative symbol indicates that the work has been done by the gravitational force. So this is all about our gravitational potential energy. I'll explain to you again. So let us consider our Earth, which has a center O, which has a mass M, which has a radius R. So we have a point A, which is at a distance R from the center of the Earth. We have 2 points B and C, which are separated by a small distance dx. I have also placed a particle at the point B, which is at the distance x from the center of the Earth. So now, from Newton's law of gravitation, we know that the force is equal to GMM by x squared. So, work done in moving the particle from B to C. So from B to C, that is dW is equal to F into dx. So I have substituted our force onto this equation. So I'll get this one. So total work done in displacing the particle from x is equal to infinity to x is equal to r. So I am trying to move this particle from here to here, very close to the earth. So here I don't know the exact distance between the earth and that particle. So for that reason itself, I have taken that distance to be infinity here. So x is equal to infinity to x is equal to r. So that particle can come as much close as this r. So it cannot come inside our earth. So it can come very close to the earth. So that is which is at the distance small r. So that work done is equal to integration of infinity to r into dw. This is what we have. So I'll substitute our dw onto this equation, that is gml by x square into dx. So after integration, so we are not doing the integration here. So here this integration and differentiation you will learn in your mathematics classes. So don't worry about it now. So I have written directly the answer. So work done can be written as gravitational potential energy. So work done is equal to potential energy is equal to minus GMM by R. So potential energy can be named in the term V is equal to minus GMM by R. So this is the expression for gravitational potential energy. So this negative term, negative symbol indicates that work has been done by the gravitational force. The next topic is escape speed or escape velocity, which is represented by the term VE. So the minimum speed with which an object escapes from the gravitational pull of Earth is called as escape speed or escape velocity. So we all know that when a stone is made to throw upwards, it will reach certain height and then it will return back to the earth again. So I hope you all know this. I have taught you this in our introduction class itself. So imagine that you can throw an object with certain amount of speed and that object will never come back. So that particular speed or that particular velocity with which you can throw the object and it can go beyond the sky and it can never come back, that particular speed and that particular velocity is called as escape speed. So even our rockets, our modern day rockets, even they are made to go upwards. So, but they'll never come back again. So they are made to go out of the earth. They are not to come back again. So people don't want to come back the rocket again to the earth. So they'll be given certain amount of velocity. With that particular velocity, they go out of the surface of the earth. Okay, that particular velocity itself is called as escape speed or escape velocity. So the next one is escape energy. So escape energy is the minimum kinetic energy with which an object escapes from gravitational pull of Earth. So I'll explain this. So when an object, if we want an object to go out of our Earth or out of our Earth's gravitational field, so it should have minimum amount of velocity. I told you that in the escape velocity. So to gain that velocity, it should be given minimum amount of kinetic energy also. Without that minimum amount of kinetic energy, the object can never go out of the earth. So that minimum kinetic energy with which an object escapes from gravitational pull of earth is known as escape energy. So this escape energy has an expression. So here I have written the minimum kinetic energy. So we know the expression for kinetic energy. So that is half m v square. But what we have here is half m v e square. We don't have the ordinary velocity here. Which velocity we have is escape velocity. So only that difference is here. Okay. So escape energy or kinetic energy is equal to half m v e square. So this is the expression for escape energy. So these two definitions, they are very, very important. So they are repeated in most of the question papers. So you have to know this. The next topic is expression for escape speed. Expression for escape speed. So according to law of conservation of energy. Law of conservation of energy. So what does law of conservation of energy says? Energy can neither be created nor be destroyed, but it can be transformed from one form to another form. So this is what our law of conservation of energy says. I hope you all know this. You have learned in your lower classes itself. So according to law of conservation of energy, a body can escape from the gravitational pull of Earth. A body can escape from the gravitational pull of Earth if the escape energy of the body is equal to potential energy of the body. So what is the escape energy of the body? We have learned that. So half m v square is equal to what is the potential energy of the body, that is g m by, so gmm by r. So gmm by r. So this is the expression for potential energy of the body. So but I'll replace the small letter r with the capital letter R. Okay, so because we have only one radius, that is R. Okay, so here I have not taken the negative symbol. So I have not taken the negative symbol because so here work has not been done here. So work is still pending here. So work has not been done. So the object is still on the earth. It has not gone outside the earth. So for that reason itself, I have not taken the negative symbol. So if I had taken negative symbol, it would have represented that the negative symbol says that. So the work has been done by the gravitational force. So here work is not done at all. So for that reason, I have not taken negative symbol. So here m will get cancelled. So I'll cross multiply this 2 to the right hand side. VE square is equal to 2G m by r. So after this, VE, I'll put the square to the right hand side, that is square root of 2Gm by r. So we know that G is equal to Gm by r square. I hope we know this. This is the expression for gravitation, acceleration due to, this is the relation between acceleration due to gravity and gravitational constant. So this is the expression for acceleration due to gravity. So gr square is equal to gm. So I can write in the place of gm, gr square. So I'll replace gm with gr square. So VE is equal to square root of 2 gr square divided by r will get cancelled. VE is equal to square root of 2 gr. So this is the expression for escape speed or escape velocity. So if we need to calculate the escape velocity of a certain planet, so we need to know the acceleration due to gravity upon that planet, and we need to know the radius of that planet. So if we know that information, we can calculate the escape velocity. Okay. The value of escape velocity of the object on the surface of the earth. So escape velocity of earth is 11.2 kilometer per second. So whereas the escape velocity of the moon is 2.37 kilometer per second. So the escape velocity of earth is 11.2 kilometer per second. The escape velocity of moon is 2.37 kilometer per second. So an object should be thrown at this speed, 11.2 kilometer per second, to go out of the gravitational pull of the earth. So the distance between our Mandya and Mysore is around 40 kilometers. So for people it is around 40-42 kilometers, it is around that value. So 11 4s are 44. So you need to reach Mandya to Mysore in just 4 seconds. So if you could reach in that speed, you can go out of the earth. So this is what it is. So the escape speed of earth is 11.2 kilometer per second. So remember this. Earth has an atmosphere, whereas moon does not. So we all know that earth has an atmosphere, whereas moon does not. Explain why. So this is a basic question, so which everybody should know. So this is very simple. So we have lot of type of gases on our earth. So we have many type of gases: oxygen, helium, nitrogen, carbon dioxide, carbon monoxide, CFC, many more. We have lot of gases on our earth. So what this gas molecules can do is they go randomly from one point to another point. So they can go from here to here, from here to here. They can go from anywhere to anywhere. So thus gas molecules will travel in certain amount of speeds. So they'll have a certain amount of thermal speeds. So they'll generate heat. So that's why it is known as thermal speed. So they'll travel in a certain amount of thermal speed. Even though they have that thermal speed, they cannot exceed the escape velocity of our Earth, which is 11.2 km per second. So they cannot exceed that speed. So they can reach up to 8 kilometers per hour per second, 10 kilometers per second. So 11.2 kilometer per second is very difficult for them to reach at that particular speed. So even though if they try very hard, they cannot escape out of our Earth. So this is the reason why our why we have the atmosphere. So all these gases, they are bound to the Earth, so we have atmosphere. Whereas when it comes in the case of moon, what happens in the case of moon is, so the escape velocity of moon is very small. So that is, it's 2.37 km per second. So these gas molecules on the surface of the moon, they can reach that particular speed, 2.37 km per second. So that speed, they can reach that particular speed very easily. So for that reason itself, the moon cannot hold those gases. So they can easily escape from the surface of the moon. For that reason itself, moon doesn't have any kind of atmosphere. So but our Earth, we have atmosphere. For that reason itself, all the living beings, including human beings, so we can survive on this our Earth.